Hello, I've had a question about Unit 1, lesson number 2, and I'm looking at question number 4 on the word problems with the second part of lesson 2 homework, part B. Pilot wants his plane to track south 30 degrees east. So whenever I get into these questions that involve coordinates or directions on the compass, I'm going to give myself a little bit of a diagram here to help me visualize what's happening. So the pilot wants his plane to track south 30 degrees east. So that would be this vector right here. And this is my resultant. The reason it's my resultant is because that's what he wants. That's his end game here. So the 30 degrees, south 30 degrees is here. But since we're using the algebraic method, I need the 60-degree angle. And we know that the magnitude of the resultant it's given is 400 kilometers an hour. Next, the wind is from, and this is where it's tricky because from means that if I'm standing here at the origin and I'm looking north 10 degrees west, so if I'm looking that direction, the wind is in my face. It's blowing in my face, which means that the wind is actually pushing this direction right here. So there's 10 degrees, so that means the angle we want to use is 80 degrees. The magnitude of the wind is 80 kilometers an hour, so fairly stiff wind. So we want to know what heading should the pilot steer and what airspeed should he fly. So we know from vectors, it's the same as algebra, our resultant is always equal to the plane's velocity plus wind. In this case, we're looking for plane velocity, so I'm going to subtract wind from both sides. So the equation I'm going to work with is, I'm going to take my resultant and subtract the wind vector. All right, so there is what we're working toward. So over here, my resultant minus wind, excuse me, will equal my plane vector. So the resultant, it is in the bottom quadrant, which means my x values will all be positive, my y values will be negative. So 400 cos 60 I. So that is my x component for the desired plane speed. Oops, and I said it's going to be a negative y component because it's in the bottom quadrant. 400 sine 60j. My wind is in the same quadrant, so it's going to be positive and negative. So it'll be 80 cos 80 I and 80 sine 80j. So now I'm going to go ahead, I'm going to do those calculations down the column here. All right, and I'm going to make sure I include those negative signs because I am subtracting negatives here. So I'm just going to pause the video and do the calculations for us. All right, so I paused the video just to do the calculation. So I subtracted down that column, and I get my final, or the plane components, to be 186.1i. and minus 267.6j. So those are the x and y components. Now what we need to do is we need to convert this into magnitude and direction. So the magnitude of your plane vector will be, so the magnitude of the plane vector is the square root of your x component. Smart board's kind of gone funky. So the plane vector is equal to square root of my x component squared, 186.1 squared, plus negative 267.6 squared. So my resulting plane velocity, 186.1 squared, plus negative 267.6 squared. Square root my answer, and we get 326 kilometers an hour. To find your direction, when you're using the algebraic method, it's always your y component. And I don't need to put the negative sign in for the 267 because I already know the direction. I know that, oops, change colors here, I'm on the positive x-axis, and because of that negative, it's the negative y, so that means I'm going to be heading east and south for my final answer. So punching this into the calculator, tan inverse of 267.6 divided by 186.1, bracket, I get 55 degrees. That means that, therefore, the plane should head 326 kilometers an hour in the direction of, let's head east, 55 degrees south. All right, and that is the same as south 35 degrees east. We're just reading off of different axes. All right, so just make that point right here. So if this is my direction, said east, 55 degrees. Well, 55 and 35 gives you 90, so it depends on which axes. Our algebraic method will always read from the east axis. If you have any other questions with that, let me know, and I'll see what I can do to help.